The next step in the process, of course, is baking. So we're going to use a convection oven. It's very similar to what you might have at home in your kitchen if you put the convection mode on. So Ryan, if you could, please open that oven. We'll place those in here. We're running at what temperature, Ryan?
350 degrees.
350, and those are going to be in there for about 30 minutes, 25 to 30, and we'll check it occasionally. Now, one of the things in a commercial facility in the oven we would do, it typically would use a tunnel oven. So that's a very long oven with a chain belt that goes through it, and it's going to take it into that oven. So those could be upwards of 100 feet in length. And it's going to bring it into that first zone of the oven where it's actually just going to warm the product. Then we're going to raise the temperature in the middle zones to begin the baking process. The reason we start out a little bit lower temperature is if we have a high temperature all at once, we can get what we call case hardening, and that's where the external part of the treat actually forms a hard shell, and that prevents the moisture from inside the treat from escaping out into the ambient air. If we end up with that case hardening and the moisture is trapped inside that biscuit, once it goes through the end of the process, we can get a condition where there's too much moisture inside, but it's dry on the outside. And that moisture that's trapped inside then, after packaging, starts to migrate, creates a microenvironment in the package, and anywhere there might be some mold spores, we start to get growth of mold and we get moldy product. So the idea here is to gently or start the heat process in a little more gentle or lower temperature so that we start the warming process throughout, so we get the moisture inside the middle of that biscuit to become active and start to migrate outside into that lower moisture atmosphere that's inside the oven. Then we would bring the temperature up in those middle sections, and in the middle section we're trying to get the cooking process. So that's some of the gelatinization of the starch. We're trying to get some structure formation, so it's actually starting to anneal or adhere together. And then towards the end of that process, of course, in that middle section, we're still driving off some moisture. At the end of the process, we're going to try to drive off the rest of the moisture. And because the moisture or the water activity is very low in the biscuit overall, we start to get some browning or some color development, and in some cases some flavor development. And that's where the structure is then finally sealed into its condition. Coming out of that last section of the oven, we would go into a cooler, and we try to bring the entire product temperature down to something equivalent to the ambient conditions. If we don't bring that temperature down, the moisture that still might be trapped in that biscuit relative to the temperature and the humidity of the packaging container can cause, again, that moisture to be active and migrate out into a microenvironment of the package, and that's where we get water droplets, and those water droplets end up causing mold. So a lot of the process that we're talking about here is trying to prevent mold, get the color, the texture, and the structure formed, as well as converting some of those starches into more gelatinized or cooked starches so that they're more nutritionally available or digestible. So now we have removed the biscuits from the oven and let them cool just a little bit. This is treatment 1, treatment 3, treatment 4, and treatment 5, the way in which we've done it previously. So if we look at the control treatment here, you can see that we got a nice shape, and we're getting a little bit of rounding as it started to rise. We weren't really trying to get a rise or leavening out of this formula, but it may be a function of our oven and our oven temperatures being a little bit more aggressive than we wanted. So one thing I'm going to show you here is on the bottom, as it began to rise, you can see that we've got some cracks. The cracks are along the length, so that probably doesn't weaken the biscuit all that much. If we break that open, it's still not quite done. It probably needs to be cooled a little bit more. And so clearly we've got some rising, we've got a little bit of case hardening here, and it's still pretty soft inside. So that's material that would be doughy, and that internal moisture would give us some challenges in regards to mold prevention. But the bottom line is these are a little bit more formed and intact than the other treatments. This is the one with the lard, and you can see that there's a slight difference, or excuse me, the the vegetable shortening. You see there's a slight difference here between the vegetable shortening and the oil in treatment 3. Treatment 3 behaved much the same way, and again, we probably had some case hardening and we had some leavening or action there where we got some increase in the dimension of the dough inside. And again, it's also soft. So we probably need to do some more work on our oven and lower our temperatures at the start and increase them over time. All right, so those were the wheat-based. You can see that they actually form nice-looking biscuits or treats. But if we go over here to the sorghum, and this is treatment 4, so it didn't have any binding elements to it. It is creating a full biscuit, and we don't get the longitudinal or the lengthwise cracks and fissures, but just like it went in after we cut those, they have the cross-sectional cuts or cracks. They did a little bit better job of baking, partly because they're thinner and they didn't rise. So they were all made to the same depth. So you can see here, there's a pretty substantial difference. So these wheat-based ones, we got a little bit of rise out of those. So they're pretty crumbly. They wouldn't suffer very well if we had them in a mechanical process for conveyance and packaging. So this is the final treatment. This is the one where we added a little bit of gelatin. We had to add a little bit more water, if you recall. It does give it a little bit more tensile strength. We have a lot of cracks in there, so it didn't really form a nice dough. When we sheeted it, it is still moist in the middle. You can see here that it's also crumbly. It's a little darker, kind of tan in color. And so the gelatin also may have had an influence on color development. Okay, we've talked quite a bit about the difference in the type of process. And so the process that you've seen demonstrated here has been a sheeted and cut. And sheeted and cut is not an uncommon practice, especially in the biscuits and crackers industry. But most of what we use in pet food is a rotary molded. So this is an example of what we've been making in this demonstration. And you can see that it's sheeted and we've cut them, and one of the things to note here is how rounded they become. And so it's a function of the way in which we've made our product versus in a rotary molded where the material has been pressed into a die cavity. We see a little bit more clear, sharp lines. We can get some design characteristics, like in this case, we have the ends of the bones demarcated. These are the docker holes that would have been on the die cavity itself. We can also see in this example where there was a little bit of a tailing, and that's where the knife on the rotary cuts off the dough as it's coming around the rotary, and so it's cut that off, and then it lands on a cloth belt. On the cloth belt, it takes adhesion or pressure to do that, and so I'm not sure if you can see it here, but the base of this is a little bit rough. You can see what looks like material. In essence, it's almost like a canvas. And so it adheres that treat as it's coming off of the rotary and pulls it out and puts it onto the chain belt going into the oven. Another characteristic that makes it easy to identify whether something has been sheeted and cut is and baked in a single oven is the bottom here. And you can see from where the contact points were, that conductive heat that came from the chain belt onto the biscuit, we can see some darker coloration here. So if I'm walking in to look at a product, I can immediately tell that, hey, this is a rotary molded product and it was produced on a tunnel oven. Whereas this is a sheeted and cut product, some of the shapes are a little irregular, we get a little bit more rounding, and we have a little bit more uniform color formation on the bottom of the biscuit. So that quickly concludes our demonstration on baked foods and treats. A couple of key things to walk away with. Number one is that the flour or the consistency of that material and the proteins that it brings in has some influence on the way in which those behave as they go through the mixing, the water addition or hydration, as well as the sheeting, cutting, and ultimately the cooking process. The wheat and the wheat gluten tended to help quite a bit in giving us a little bit more structure. We do see some color development changes between the types of oils that we're adding. So the point of all of that is that the ingredients do matter. It's not just that we add one ingredient or another because we like them. From a popularity standpoint, it really comes down in many cases to the functionality of those ingredients and identifying which ones are necessary to give us a resilient, quality, textured treat that has the right color, flavor, and aroma. The other piece of this is that when we're making these biscuits, we're selecting our ingredients, we're mixing them, we're adding the dry ingredients, mixing those, then we're cutting in our fats and oils, and then we're adding our moisture. We're bringing that into a mix of uniformity to where it gets to the right consistency. Then we're going to go through the baking operation. The baking operation is going to help us with structure development, drying, the cooking, so that we're converting some of those starches into something more digestible, and then finally color, flavor, and aroma development at the end, and finally to give you the structure that you need of that product so that it meets the customer's requirements. These would then be cooled, as we mentioned, so that we don't get mold development. One of the things that baked products that we always wrestle with is molding, and then those would be packaged and ready for sale to the consumer. On behalf of my sidekick, Ryan, and myself, thank you all for joining us for this demonstration.